Hello world. In this video, what I want to create is the guessing game in the C programming language. So you might be familiar with the guessing game. You might have played it when you were younger. You tell your friend, you say, think of a number from 1 to 100 and I can guess your number within a certain amount of turns. And then you say, but there's a catch. Every time I take a guess, you must tell me if my guess is either too high, too low, or if I guessed your number correctly. So here we go. We're going to kind of show how this guessing game works here in some comments. So first you'll say, think of a number from 1 to oh from 1 to 100, and you'll say I can guess your number within maybe 7 turns. And then your friend is, and then you'll say, or you would guess, is your number 50? You say that to your friend, and then your friend will say something like, no, you need to guess a higher number. And then you'll say something like, is your number 75? And then your friend will say something like, no, guess a higher number. And then you'll say, maybe, is your number 88? And then your friend may say something like, no, guess a lower number. And then maybe you'll say, is your number 81? And your friend will say, yes, you guessed my number within 7 turns, specifically 4 turns. And then you're done playing the game and your friend won. So how does this actually work, and how can we guarantee that we can always guess our friend's number within a certain amount of turns? Well, that's pretty simple. Let me go ahead and copy this first line here and paste it here. I'm going to put how this works. And think of a number from 1 to 100. So 1 to 100 is our range of numbers of possible guesses that our friend could be guessing or thinking of. And we say, I can guess your number within 7 turns. So where do we get this number 7 from? Well, it's pretty simple. We did log base 2 of 100. And that is about 7 given some rounding. So where we get this 100 from? Well, that's our range of numbers, 1 to 100. Or more specifically, it's our high range, which is 100 plus our low range, which is 1 minus 1. So that's how we get our number 7. And we can always guess the correct number within 7 turns using a divide and conquer algorithm. In this case here, given that range 1 to 100. So it would take at most 7 turns. So if we said we could do it within 8 turns, 9 turns, 10 turns, or whatever, anything that's higher than 7, then we can always guarantee that we can guess that person's number. However, if we say that we can guess their number in turns that are less than 7, such as 6, 5, 4, 3, 2, and 1, then we're not always guaranteed to guess their number correctly. So now how does the algorithm work? Well, I'm going to copy this here. Actually, I'm going to copy this first line where we choose a number. We just guess a number. It's not random. What we're guessing is half of the numbers. So is your number 50? The number 50, where do we get that from? Well, what we did was we did the high range, which is 100, plus the low range, which is 1, minus 1, which is, of course, our possible number of guesses, or our range, and then we divided that by 2, and that gives us the number 50. So here, right now, our range, or our possible number of guesses, is 100. So it's 1 to 100. And I'm going to put here 100 possible guesses. And these are all the guesses that we can guess. We want integer values, so 1 to 100. And these are all the numbers that our friend could be thinking of. But this is where the algorithm comes in handy here, is when your friend gives you feedback. When they say no, they tell you that you need to guess a higher number. So when they say this, they're actually now telling us that our range is not 1 to 100 anymore. Our range now becomes 51 to 100. I'm going to put range here. So this is our new range. And it's going to equal 51 to 100. Okay, so that means that we need to guess a new number with this new range. So what we say is your number 75? So where do we get the 75 from? Well, let's do some calculations again. We got this number from our high range. So our high range is 100 plus our low range. What's our low range now? Our low range now is no longer 1. Our low range now is 51. So plus 51 minus 1, and then we divide all of that by 2. And this gives us the number 75, or 150 divided by 2, which is 75. So right now our range is 51 to 100, which means that we have 50 possible guesses or numbers that our friend could be thinking of. So already we have divided the possible choices by half. So this is good. And now we're gonna get some feedback from our friend, or the user in this case, for the program that we're going to create. And they say, no, guess a higher number. So now they're telling us that the new range is no longer 51 to 100, but rather 76 to 100. Okay, and so what this means is that now there's only 25 possible numbers left to guess. Okay, so let's guess a number then. So we say, is your number 88? Where do we get the 88 from? This right here you're going to have to pay attention to. So right now our high range is 100. Our low range is 76 minus 1 divided by 2. This equals 87.5. Now we want to only guess integers. We don't want to guess decimals. So we need to round either up or down. In this case, I rounded up. So if we round up, we get 88. And I'm going to put round up here. And we're actually going to round up for all of these. So we're rounding up. And when you round up this value here, we still get 50. When you round up this value here, you still get 75. And when you round up this value here, you get 88. Okay, so right now our range is 76 to 100, which is, of course, 25 possible guesses. So now we need feedback from our user here, or our friend, to tell us yes or no. Is that their number? They'll say, no, you need to guess a lower number. So what this tells us now is that our new range, or our possible number of guesses, is equal to 76 to 87. So why 87 and not 88? Because they have told us that 88 is too high. So now that just gives us the range 76 to 87, which is 12 possible guesses. Which again, we have divided our range, or our possible number of integers that we could guess, or that our friend is thinking of, down to 12. So it was 100, then it was 50, then it was 25, and now it is 12. Okay, and let me just put here 50 um, possible guesses so that you can still see a pattern here. Okay, so next up, we guess a new number. Is your number 81? Where do we get that 81 from? Of course, I'm going to show you. We get the 81 from taking the high number, which is now our high range is no longer 100, but rather it's 87. So we do 87 plus our low range, which is still 76, minus 1. Take all that divided by 2, and we need to also round up. And we get our number 81, which in this case just so happens to be the number that they were thinking of. So they say, yes, you guessed my number within 7 turns, specifically 4 turns. And so that's basically how this divide and conquer algorithm is going to work, and how it's going to work with this guessing game to make sure that we always guess the number. So I'm sure you guys are tired of me hearing this explanation of how this works. Let's go ahead and get down to coding, get down to the nitty gritty. So first we're going to include some libraries. Include standard input output.h. Next we're going to include the standard library, standard lib.h. We're also going to need the library math.h. This will be good for rounding up and for doing the logarithm mathematics here. So it has 2 functions. It has more than 2 functions, but we're going to use 2 of its functions. The log function, which is log base 10 and not log base 2 like we need. So we have to do a little bit of math for that. And we're also going to use the ceil function, which stands for ceiling, where you round up. So it's going to basically be our round up. Everywhere we have round up will be ceil if we want to do it that way, or we can use it to round up our log base 2 here, which should round up to, whatever the maximum number of turns are. Okay, so let's create our main function, main void, and I'm going to go ahead and start declaring some of the variables that I know we'll need. So declare variables. And we're going to need a low range. So our low range in this case was the number 1. So I'm going to make it 1. And then we're going to need a high range. So in our example, the high range was 100 here. So I'll take 100. And then we need our range, or possible guesses. So I'm going to call it possible guesses. And it's going to equal our high range plus our low range minus 1. So you've seen this here: high range plus low range minus 1, high range plus low range minus 1, high range plus low range minus 1, and you've even seen it here: high range plus low range minus 1. So I think it's pretty good to go ahead and put this calculation in one variable, so to make it a little bit easier on the eyes and for programming purposes. So now we're also going to need the maximum number of turns that it takes to guess the person's number. In this case, the max turns was 7. And remember, we did 7 log base 2 of 100 plus 1 minus 1. So we're going to need to do some logarithmic math here. So we're obviously going to need the possible guesses. And that's going to be, we need log base 2 of that. So how do we get the log base 2? Well, this is log base 10. So log base 10 of possible guesses divided by log base 10 of 2. This gives us the log base 2 of possible guesses. Now, what I'm going to do is, I think I'm just going to take the possible log base 2 of possible guesses. That's going to give us some value, but I want that value to be rounded up. So I think this gives us something like 6 point something maybe, and then round it up gives us 7. So I want to round it up. So I'm going to use the ceil function to take that whole value, this log base 2 of possible guesses, and round it up. So now this should, if this gives us 6 point something, the ceil should give us 7, the ceil function. And I'm going to put here, this is log base 2 of possible guesses rounded up. Alrighty. So let's see, what else will we need? We will need the guess that the computer is going to guess. This will be the number 50, 75, 88, 81. We need this number to change. So I won't assign anything to it yet, but I will put a comment. The number that the computer guesses. And here I put range. Range of possible guesses or numbers left. All right. And then we're going to need our player or opponent's or friend's response back. So this variable will give us the no, guess a higher number, no, guess a lower number, or yes, you guessed my number. So we're going to have to give it 3 choices. So we're going to make it an integer. I make, 1 for, let's see, we'll say 1 is yes, you guessed my number. 2 will be no, guess a lower number. And 3 will be no, guess a higher number. Okay, and then maybe we want to keep track of the number of turns as well. And we'll set that equal to 1. And maybe I put keep track of the number of turns or guesses. So here this would be turn 1 here, or guess 1, turn 2 here, or guess 2, turn 3 here, or guess 3, and so forth. Okay. So now let's maybe do a print statement. And we'll say think of, matter of fact, I'm just going to copy and paste this up here. Think of a number from 1 to 100. I'll guess your number within 7 turns. Paste it here. But I'm going to make it a little bit more varied because we can change our range. I'll make this %d for low range, make this %d for the high range, and make this %d for the possible number of turns it'll take to guess the number, since our range is going to vary. Put a \n for next line or new line. And first one is low range, then the high range, and then the max turns. Okay, so let's give this a run just to Make sure, think of a number from 1 to 100. I can get your number within 7 turns. Perfect. So this max turns calculation is working properly. Alrighty. So now let's do a divide and conquer algorithm. So this is the actual guessing game. So I'm going to create a loop. It's going to be a do while loop. You can see here that we are obviously in some type of loop here. So we need to do a loop. And we're going to do this loop while, let's see. We want to do this loop while the player let me make sure I get my parentheses correct. So while the player does not equal 1, so while they don't tell us, while they don't say, yes, you guessed my number correctly, we're going to keep doing this until they say that. And we must make sure that the number of turns that we take are less than or equal to the max turns. So this is how long this loop is going to last. It's going to last while the player does not say that we found their number, which is player does not equal 1, and the number of turns does not equal the maximum number of turns needed to guess the player's number, because then we know that something went wrong there. Either our friend lied or whoever's using this program maybe made a mistake. Okay, so first thing we want to do, maybe we'll make a few print statements, and we'll say something like, is your number some guess, and then \n, and then we'll put the guess there. And now we never created the guess, so I need to create that first, really. So here we go. What we're going to do is create or update the new range or possible number of guesses. So our possible number of guesses is equal to this. And so our guess is going to equal the seal of possible guesses divided by 2.0. And so make sure our guess is an integer. And our possible guesses divided by 2.0. So remember, this is just going to be our round up and divide by 2. Round up, divide by 2 here. So you can see our, again, inside here is our possible guesses that we can have, the possible number of guesses. And that's all we're doing here. We're just making it into one variable called guess. So now we can guess that number each time. So the number is going to be something like 50, and then 75, and then 88, and then 81. Okay, so we're going to need to know our user's feedback. So we'll say 1 is yes, you guessed my number. So I'm just going to copy and paste that here and put a new line. And let's see, I need to do that 2 more times. 1, 2, but we're going to need the number 2 for no, guess a lower number. And we're going to need the number 3 for no, guess a higher number. And then we're going to need to actually scan in the user's input. So let's see, we call it the user's input player. So this right here will actually get the player's feedback. So this is the no, guess a higher number, no, guess a higher number, no, guess a lower number, or yes, you guess my number. Okay, so perfect. Now we need to change our range. So anytime they give us this input here, this tells us what our new range is going to be, right? Every time they gave us a response, we have a new range or the new possible number of guesses. So we have to update that. So if the player chose the number 3, which is no, guess a higher number, then that means that our low range is equal to our guess plus 1. So they're saying guess a higher number, so our low range increases. So this right here, we're updating the new low range. Okay. Else if the player equals 2, if they chose the number 2, this ain't no, guess a lower number. So that means that our high range needs to change. So our high range equals our guess minus 1. So here we are updating the new high range. And I want to put else just in case they choose anything other than 1, other than 3 or 2. If they choose something like 0, this would be kind of like a fail-safe type of thing if they happen to put in something that we didn't expect. But for now, I'm just going to put in else if the player equals 1, then we want to break the loop. So we will break out of the loop because we guessed the player's number. Okay, so hopefully they don't put any number or anything other than 1, 2, or 3. I'm pretty sure that may break the program. Okay, so what else we need to do? We need to count the number of turns. How many times does this loop run? So our number turns is called num terms. So num turns, and it's going to keep incrementing by 1 each time. So increment the number of turns. And maybe I want to start the number of turns at well, yeah, maybe I want to start it at 0. Okay, so now we need to print the results. If num turns is greater than max turns, then there was a mistake. And we're going to printf you made a mistake. You've exceeded the maximum number of turns. Put a semicolon there. Else, we can print I guessed your number in %d turns, maybe exclamation mark, And we have to say what percent d turns is num turns. So let's go ahead and give this a try. Okay, so think of a number from 1 to 100. I can guess your number within 7 turns. Is your number 50? So right now our number is going to be 81. Let's give this a try. So is the number 50? No, they need to guess a higher number. So we're going to put in 3. Put that back over here. 3. Okay, so they say, is your number 75? We say no, guess a higher number. Choose 88. Is your number 88? No, we need them to guess a lower number. So that's 2. Is your number 81? Yes, that was our number. I guess your number in 3 turns. Let's see, turn 1, turn 2, turn 3, turn 4. So maybe we do need to make this number turns equal to 1. And let's give this another try again. So no, guess higher. No, guess higher. No, guess lower. And yes, I guess your number in 4 turns. And also I misspelled number here. But that is it. So thank you guys. I hope you really enjoyed this video. I know I really enjoy this program and this game. Please leave likes, comments, questions. Please subscribe and become a Patreon or Patriot on Patreon. I never get that right. And please look out for more videos. And I'll see you guys in the next video. Thank you for watching.